Alright, so I'm going to make a video about how I designed part of this drone. It's going to be specifically about the battery part, and you can see that here. This is an internal piece, so it can't actually be seen from the outside, but I got carried away with it, and it's kind of a benchmark, I guess, so I thought it'd be worth going through this. I asked quickly a few people if they needed any things that I should talk about while working on it, and it was if I had a concept, how I started off, blocking it out, techniques for modeling, breaking down to shapes, parts, panels, and shape language. So I'm gonna go through that. I'll kind of go and break it through all the steps along the way. These aren't all the saves. It took quite a lot of saves to get to this, and overall it took 12 to 13 hours, as you can see, to reach this point. However, this was after I had some critiques, so this is actually more representative. This was 11 straight hours. This is started at 12, it started at midday and ended at 11. So that's the best way of putting it. But yeah, and then this will kind of show you how I got to that point. Whenever I'm starting something like this, I'll have a mood board. Now this is not the original mood board. For some reason it got corrupted, which is going to kind of mess up the next video that I have to do, but whatever. So this is a Koenigsegg. I think these are all car battery systems actually. Yeah, Rimac, yeah, they're all car battery systems. This was not a reference really. This is kind of like a starting point, and I think it helps with the overall idea. You can kind of see with this battery, it's very sleek, mostly rest area, and then there's like a small area of detail here. But here as well, rest, pretty much rest, and then detail right on the edge. Now, if you're wondering what I mean by rest and detail, a lot of my design language is influenced heavily by Alex. I think I've shown this before in a previous video that I made, but he's got this tutorial, and this tutorial was kind of like, was it 6.5 hours? No, 10 lessons. No, I'm trying to find how long this is. 11 hours, yeah. So it's 11 hours in total, but this is like a accumulation of everything I was told in person to person over the course of pretty much 2 years, squashed into 11 hours, because at the time I met him there was no video like this. But this kind of gets you'll kind of get an idea of where my basis is coming from. So it kind of goes through, vocabulary, how to learn hierarchy. It goes through the different, I guess, modules that you kind of apply towards them. So when I'm talking about how I made this, I'm not gonna kind of explain everything, as it would take too long, probably 11 hours. But you'll kind of get an idea of where I'm heading and why I did what I did. Probably not the idea behind why I did it, as that is more in this video, and it's taken years to implement it, but you'll be able to get an idea of how I implemented it. So that's just a good point to mention out. But yeah, so let's get started. Obviously this began with a cube. I just made this just now though. My earliest save actually starts around here. I'm not sure why. I don't think I made a save before this. But the main idea with this, if you look back at the reference, was to have a clean surface and then like a kind of concentrated area of detail. And if I look over here, you can see her without the wireframe on. It's relatively clean. From like hair to hair, it's totally clean in fact, but all the detail is clumped around this end point, which is where it would connect, as you can see by the cabling area. But the back, pretty simple as well. That's because mostly not laziness, but I ran out of time. But yeah, I was trying to get that kind of detail to rest area contrast, and keep that along the way. So this is the earliest save that goes back, but with this, you can see that I was just trying to block in the basics, I guess. I normally model half, so that's why I've only bothered with the left side. I know I would cut it down the middle, align it, and then delete the other side. That's why it's only on one side here. But so here, for example, I knew there was going to be a circular mountain point, and I knew that I wanted to have like a bolt here. And this was kind of the first iteration, I guess, where I slammed a cylinder. So let's have a look. Yeah, you can kind of get the idea. When I'm designing something like this, I'll think of the function first. So in this case, hang on. Yeah, I knew a bolt was going to be here. Reason being, I was thinking, oh, okay, it's going to have mounting points here, there, and also at the back, but not connected to the battery, but connected to a kind of external cage. So with this, I thought, okay, if there's something that's going to go in here, then you'd have like a round bit around here that could, you know, be interesting. So that was the idea behind it. There wasn't really much more to it at that point. But I was also trying to get some interesting transition in. So you can see here it's flat, and then it kind of rolls up like a ramp, and then round, and then joins into this shape. These shapes are referred to as compound shapes, I guess, which is where you mix together shapes instead of it just being a simple box cylinder. You kind of mix bevels, and you can kind of see what I tried to do here. There's kind of a flow from around there, and then at this point, you can also see I haven't filled in the topology. So this was trying to find a way of transitioning from this flat area to the side smoothly. I'm not sure. I don't think I pulled it off in the end. But you can see kind of the free form. I'm not worrying about topology at this point. This is like one huge n-gon. This edge here isn't connected. None of it matters. It's just about getting the form to be how you want it to be. But yeah, that's the first part. Let's have a look. So next one seems pretty much the same. Okay, so third one's better. Yep. Let's have a look. So at this point, I've added in the. I think I booleaned that in. It didn't matter too much because it was flat, and I could just draw the reinforcing edge loop. Hang on. Yeah. So this bit going around here, and that way it doesn't cause any artifacts. Mine is not very good with booleans, so I always try and support it with stuff like this, and then sometimes you'll have to join an edge or something. Let's see if that works. Yeah, it works fine, because Maya will have its own trouble if you don't kind of join the edges. But what I tried here as well was to continue the transition. You can kind of see the ramp going up, and then it kind of reaches the flat point, and then it starts going down. I've never seen someone do a shape like that, so it was just, I don't know, it was kind of a daring thing to do, and I was like, all right, let's try it and see what it looks like, and I was happy with the result. You can see here as well, these are just bevels, so if I go to the one before, to pull off that, you literally just bevel it, and it should make that kind of shape. I say should, and it's not going to. It's going to do some weird shit. No, it should be alright. Let's have a look. Yeah, so you can see, and then segments, and that will smooth it. If I look here, I think it's depth. You can also control whether you want it out or in. I always go in. The only time I've ever gone out was for making kind of like ornate wooden frames. They have shapes like this, but I hardly ever use it. But sometimes it's good for making it less strong and more strong depending on what you need at the time. So that was just a way of transitioning it into the side here, so it kind of smoothly goes in and then stops here. This is a simple extrusion in of a shape that was already there, so nothing really special there, and the rest of this is mainly untouched. Alright, so going to the next piece. With this, it seems that I did a kind of split, and I added this bevel over here. Now this split, if you see here, so it was all one mesh at this point, but you can see I'd already cut out, not cut out, but I'd already drawn this line, as that's where I intended to make a panel, and here it's actually separate, so you can see that. And this is a good place to actually answer how I do paneling. So, alright, how I go about paneling is, because I remember when I started, it was one of the bigger problems. It's really not that hard though. I don't know why, but it always seems like a difficult thing to do. So I used the multi-cut tool, so that was quick actually. So shift right click, multi-cut, is right there. I'm not sure exactly where it is in here. Edit mesh tools. Okay, so mesh tools, and then this there, multi-cut. But shift right click is just the fastest way for me. Let's say I wanted to create a panel on this area here. I would multi-cut, and you can kind of draw the line wherever you want. If it works. Okay, I know what's happening. I'm gonna have to hide this. All right, let's try that. So I'll draw the line up, and yeah, let's just. It doesn't really matter at this point. Actually, I can. Yes, yeah, fine. So if you want to do 90 degrees, Control and Shift can allow you. It will kind of lock it to 90. So let's just select that there. Press Enter. This here is not 90. No. This part is not 90 degrees, and that's where you would need to scale it in. So let me just make that extreme. Scale it in, and then you can like kind of lock it to where you're trying to lock it to. That's V. So V will allow you to lock it to the edge that you want. So if you want it in line with this edge, V, and then you drag to that edge. You want it in line with this edge, V, drag to that edge. So that's how you kind of ensure that everything is always 90 degrees. If I take this, let's say, yeah, we'll leave it here. Actually, sorry, let me make this easier to see. Display, standard. Alright, yeah. So yeah, and I want this panel to go down here. Thanks. And here, and then to the center. Right, so there's two ways of splitting this into a panel. You can either select the entire area. Let's say, yeah. So, this is not the way I do it, but I'm just showing you this way anyway. Alright. And that, and then you can extract faces, and what that will do is it will separate it entirely into two separate pieces. So that's what I would have done. Hang on, if I just undo this quickly. Oh no, not that far. Alright, cool. So that's what I would have done for this bit here. You can see it's separated, but there's no gap. How I normally do it, and it's less destructive than separating like that, and it's much quicker to get rid of it, as you can see, is bevel. And when you bevel an edge, it kind of gives it thickness, and then you can select the face. Sorry, zooming in too quickly, and delete it, and that is a panel. So if you want it back, you can always go across the edge. Yeah, you gotta be really careful with this, but you can go across the edge basically. I'll just show you with these three bits here, and bridge it back. Yeah, and that's like, you know, so you can see it's back, it's not destroyed or anything. That's a good thing about doing it that way. So that's how I would go about paneling, honestly. And then, of course, you can bevel it. Now, the thing is, you have to bevel beforehand if you want a smooth curve. So let's say you don't want this edge to be that sharp. You could either, like here. So this is what happens if you try and curve it after. There's chamfer, and you can see it doesn't work very well. So you've got to do it before. You've kind of got to commit to the decision before you've cut it. You can do it after you've drawn the panel, however. So here's the panel. It's not cut yet. I can bevel and then add segments, and now it's smoother. And then you can control how sharp the edge is based upon, you know, the fraction that you give it. So, for example, there, alright, yeah, there, and then you delete it, and it will be the small curve over there, and you do that for both of them, kind of thing. Here, you wouldn't do that though. You would curve the entire edge, so you can see there with the bevel, and that's how you'd go about smoothing that. And then when you delete it, it'll be a smooth curve going down the side. So that's how I deal with, I didn't go all the way, but it doesn't matter. Oh, that looks kind of cool actually. Shit. But yeah, that's how I'll deal with panels. And then on top of that, your panels don't have to have the same, I guess, inset length. So if I, hold on, because you would have seen this on my work a bit. Let's just extrude this in. Alright. If I, yeah, and then just pull this. Sorry, it's hard for me to even see this. Right. Yeah, so this was something else I learned from Alex, but you can actually vary the thickness of the panel from one side. So there you go. And so you always got to like harden the edge to accentuate it. Hang on. It's still hard to see. You can probably see it a tiny bit, but I don't know how this video is going to compress and then you might not be able to see it. So I'll just force it. Oh jeez, help me out. Oh, I see what happened. Okay. Alright, so if I pull this down, there you go. Yeah, easier to see. So, oh, hello. So this is you can see like the panel curve, I guess, and it's kind of thin and it goes out to thick. Now this is linked to 70-30 as well. So, for example, in this case, you could say this area is like 30, and then this line is 30% like to this. How do I explain this? It's 30% up this side and 70% away from this edge, for example. Yeah, so this is the 70 and that's the 30. Then inside this you then have 70% of this kind of thicker edge, and I'd say really this is more actually 60% thicker edge, 40% thin edge. And this is how like I kind of had to balance. So I would pull this edge in, right? And now it's 70-30. That gives you an idea of how like that's one decision I would make. For example, if I was building this, oh, you know what, this looks nice actually. I wish I did this the first time, but I didn't. But that's how I'd go about it. And if let's have a look. So another way of doing it is, let's say we want this edge to be the 70. I'd drag this down. Oh, hang on. Yeah, I've got to drag this down first. So yeah. So this is not 70-30. Hang on. I'm just going to force it. That is 70% thin line, 30% thick line. So it would be between these two. It would be either this one or that one kind of thing. And that's, I guess, the best way I can describe how that's a decision I would make. What I wouldn't do is that's pretty 50-50. Not totally 50-50. I think this is, I don't know. Yeah, no, it's 50-50. I can't tell, so it's probably 50-50-ish. Not that it looks bad. It doesn't look bad. I think it probably looks better because of this like inset that's there. If I was to take this, for example, Alright, what I'm going to show you as well, this is obviously going to only help for people using Maya, but if you want to, so I want to move this edge in this direction, you can press D and you'll be able to align the pivot, and then I can select the edge, and this ensures that it will move along this edge forever kind of thing. You can see how straight that line is. So that's how I would like give it thickness, but ensure that it keeps the same direction with the edge. So this has an even thickness all the way around now. If I just show you this, and though it is still relatively nice, interestingly enough, it doesn't have a kind of dynamic shape that this does, because there's more hierarchy here. There's a thicker edge here, and then it kind of leads to this kind of thin edge, and then that goes to the front. So it's these kind of things that I would think about while making it. You can see that I can't even speak smoothly. That's because I'm constantly going through different ideas as I'm talking. So you know, it is really just iterative. That's exactly why this shape took 11 hours. It's not a smooth process, but it's just, you know, yeah, you just deal with it. kind of thing. But oh yeah, damn, that is nice. But yeah, you get the idea. That is the idea behind like one kind of decision I would make when it comes to edges, edge thickness. Let's have a look at some things. I'm experimenting as I go along, but it's quite useful. Yeah. Alright. So this is thickening it, and yeah, this is literally what I do. You just experiment, see what you like, see what you don't like. This ironically looks, I think, better than it turned out, but probably because I've improved since I made this. Yeah, I prefer this now, but whatever. You live and you learn. So the next step was this one. Cool. Alright, cool. So with this part, just gonna check the previous. Alright, yeah, so this is paneling, isn't it? Yeah. So with this part, it seems like, whoa, that's a bit weird, but yeah. Oh yes, I was in the motion of cutting a panel along there. Alright, cool. So yeah, this is a paneling area. As you can see, I've done what I showed earlier, which is I drew a panel along and then I pressed delete. But I don't think I kept this designer there. But I was, evidently by this means I was probably going to boolean the cylinder into there and have a circular part in the center. But I scrapped that idea, definitely. I know I didn't do that. But yeah, I think there's not much here. Oh, okay, hang on. There is. Alright, so what I did is I had the idea of this shape kind of merging in. If I just can kind of get the idea. Yep, and then this one. So it would have been something like that, merging in as kind of like a structural support. I scrapped that, and instead I made this kind of block come out and up along. That's kind of a way of connecting like this area to the upper surface, because at this point, this area and this area, this area and this area here had been separate. And I wanted something to kind of go in between them. And that comes from, I think it's like, you're trying to build things in a way that everything interacts with everything else. And at that point, I think this point here, there was no interaction. Yeah, you can kind of see like, this face is totally separate from this bit. They're connected as in like by edge, but there's no interaction between, you know, this area and that area. And this was kind of the middleman, I guess. So it up and then over into this area. That's, I think, mostly for that bit. Alright, so here's a bit better. This seems like a 50-50 split, and I'm not sure if I kept that. Did I keep that? No, I pushed it back a bit. Alright, good. But at this point, this is definitely a 50-50 split between white here, gold there. And you can see here as well. I had an idea at the beginning of this shape being at the back and front. As I said, there were mounting points. So you'd have 4 mounting points for each battery, which would then connect to the cage. But I scrapped that in the end. But you can see that this was part of the process along the way. So it seems, I don't know, I think this is mostly just more paneling. There's not much to say about this. This is me just trying things at this point. There's no, I don't know what I was thinking at the time. Not in a bad way, but just more in a case of whatever I was thinking I was doing. So there's not much I can actually explain about that. But so let's keep going. So this is color experimentation. I find that helps a lot to color things. I did mention this in the last video. Just to understand how things are interacting with each other. Also, color is a very quick way to see how your proportions are working. So I can tell instantly that, you know, oh, there's this thin line, it follows round, and, you know, it appears in this way, this proportion of white to this proportion of gold. If it's all in one color, final, I don't know what color that is. Oh, that's a nice blue. Oh, shit. Yeah, there you go. If it's all one, then all you see is lines. You just see, like, it's kind of like line work versus something in colors. It's hard to, not hard to read, but it's hard to understand, like, the effect of this edge, or not this edge, and this one. this edge. You don't see it as quickly as if you just have like it in yellow, where you can just be like, oh, okay, I can see that this is dominant, this is not. You know, you can see the hierarchy very quickly. That's the best way of explaining it. Oh yeah. So yeah, I think that's that's good. All right, so this is 2 hours from this beginning here, pretty much a cube probably, to there was 2 hours. And at this point, I thought, okay, battery's kind of thin, and when it comes to battery packs, I would kind of put two together, kind of like how AA batteries are put together. So it was I don't know, my thought process was stack them. And this would be considered as one stack. And I wanted an interface between the stack, almost like two graphics cards and an SLI bridge. But I don't know, I don't know, like I said that like you're supposed to know what an SLI bridge is. I'm not sure. Depends who's watching. But so SLI bridge, yeah, an SLI bridge is like one of these. I'm looking for. Come on, someone must have that's 3. But you get the idea. You can connect graphics cards together with them. So imagine 2 cards and then an SLI bridge, which is this central point here. That's the kind of idea with this. There's a bridging point between 2 batteries, however, not graphics cards. And at this point, I'm just messing around with ideas. So I knew I wanted the cylinder of some type. This was a very weird shape to create. And smoothing this was not fun either. But this was kind of, I feel like the shape by this point, I was like, okay, I want to make the best shape I've ever made. So I'm going to put, like, you know, cylinders into complex areas that I wouldn't normally put cylinders into. And what's worse than a cylinder into a cylinder? Nothing, right? So that was the intention. And what I did here is I kind of booleaned in the cylinder into this flat bit. That's not too hard. And then I wanted it to kind of roll into this side of like this cylinder here. I hadn't done that before at the time, so you can see how that went. And there is a bit of pinching. There's hang on, sorry. Yeah, you can see it here. It's not perfect. This was very hard to pull off. It was, like, to even get it this good was very hard. But you can see where I went with it. And in the end, I was happy with it regardless. You can also see I did that kind of ramp thing here again. So it kind of goes in. Reminiscent of this bit here where it goes in as well. So that's kind of, that would be called echoing, I guess. That's something else you'd learn in Alex's tutorial, where it goes about having similar design language, like cues that are around the model, I guess. So there's like one there and one there. Now you can't really see them, so it's less of an effect, but it's a consistency across the model. I guess that matters. Other than that, though, so this save was mostly focused on the shapes interacting with each other. This is another example of things fitting into each other, or my attempt at it. So you can kind of see that it goes down and they kind of meet up. Not exactly meet up, because I put this in the center. So once again, like, it's like this is the middleman. Or if you look at this piece, for example, this is the middleman between these two pieces. This is the middleman between these two pieces. And there's another one here as well. This. So yeah, I hadn't modeled it yet. But you can see, like, I was in the process of modeling it, and then I'd just, you know, take the edges, extrude it. Sorry, hang on. Inwards, and then add the edge loops to smooth it in. And you can see that's now the middleman of these two pieces. No, he hasn't got any edge loops in there yet. But that's what I'm always trying to do. You're trying to just, like, what's the word? Like, meld pieces together, you know, make it fit like a puzzle. You can kind of, I think you can kind of see the idea of what I'm talking about, where things fit into other things, I guess. Because when you are starting out in 3D, you will tend to just smash cubes into other cubes, and everything's kind of intersecting. And I guess I do that only now if I'm running out of time or something. But if I can, I will build everything to fit. This drone, I think everything pretty much fit. You can see here, for example, this doesn't fit into that. So if I had more time, I would have made it fit into it, but I ran out of time. But this does fit, however, into that correctly, and it's just trying to get everything to fit in. You can see there that doesn't fit into this because of lack of time again. The issue is that it takes a very long time to get things to fit together, and this is what, 4 hours in. So 7 hours in, Jesus man, you can see there that things are starting to fit a bit better. I have not smoothed it or added in the edge loops perfectly, so you can see they don't like line up at this point, but it doesn't matter. It's getting there slowly. I've done a bit of pushing and pulling, as you can see here, versus where it was before. And it's got like a central point as well. Now this fluorescent green is the shader is called a surface shader. So you'd go and just, you know, assign new material, and then if you type surface shader, I don't know why it starts as black, but you can put out color and it will act as kind of like, it's a really bright, vibrant kind of shader that I use to imply lights. It's what I'm using on this. So that's like a blue light, if you see what I mean. This is a green light. And I use that to like remind myself of what I intend to glow when I do the render. I think I kept it, oh, open the keyshot, damn. I think I kept it in the render, unless I am. Let me close this. Close. Oh god, you are slow. Alright, yeah, so you can see there, it's lit up. And that's what I use inside the viewport to let me know that I'm gonna make it light up. But color-wise, it doesn't really matter. I didn't make it light up green. That's just for me to separate things easily. But yeah, what you can see I did here is another version of this, where I'm joining from this face onto the, like, I guess the other plane. The way of explaining this, hang on, let me explain that. I will explain that. Which one am I on? I'm on 4 hours, 7 hours. Alright, so just taking out subdivisions. Alright, cool. So these are two planes, and I'm yeah, two planes on two different axes, and I'm trying to make the shapes flow across the axes. So a really quick way of doing one, for example, is if you just do two edges here and delete these two and then join that and close these edges. So at this point, this face and this face are totally separate. With this, you've cut into this shape and you've transitioned it via a ramp to this shape. So that's like one way of interacting both planes that I find interesting. Another one is to, you know, extrude something along. So really, to be honest, I guess it is kind of the same as this, but you've kind of gone, obviously it's going to look weird, but you've gone around the outside via extrusion instead of deleting and basically intruding. Another one, which is what I did there, was you kind of extrude out there. So now it feels like it flows round, and I think even though this plane and this plane are as separate as this plane and this plane, this bit is one plane on one axis, so it's kind of connected through that. And I think that's another way of connecting the pieces. So what I'm doing so looking at this bit, I think what did I do between these two? I don't know, 7 hours. I get the idea. I don't know. What is this? What did I do? Oh, okay. Okay, so this is topology. Yes, topology. Alright, so yeah. Okay, this will help with the modeling part, because in case you're wondering how I get to these bits. So let's have a look at these two. So, Yeah, so left is concept model. This is the concept modeling. The edge flow is pretty decent on these concepts parts, but it cannot be smoothed. As you can see, it breaks under smoothing. So the main focus with this is ensuring that the edges are flowing in the right direction and things aren't too squashed. The reason why I say too squashed is because adding edge loops takes up space. So a concept model can look like it has enough space, but once you start adding in things, it won't. And I'll give you a perfect example I can see right here. Is this space here is very, very thin. So when I want to add a reinforced edge loop, let's say I'm trying to smooth this area here. I'd go up, and I will explain more the workflow behind what I'm doing right now, because some people will be like, what the hell is he doing, and why is this going to work? But so let's just merge the edges and just put edge there, edge there, edge there, edge there. Alright, press 3. Alright, so yeah, the reason that's breaking, by the way, is because it's not connected close enough to another edge. It doesn't matter that whether the topology is bad or not. So let's just connect it there, and there you go, it's fixed. So this is one edge there. Now when I do the second edge, you'll see it starts to get tight. And let's just put that there, it doesn't really matter. Yeah, so yeah, here is quite tight, and I'm normally not comfortable with that because I don't know what I'm going to make down here that may require me to go down this face, and that's why you got to be really careful with it. I wasn't too careful with it here, but it didn't matter because I had nothing over there. But yeah, if you look at these two, for example, you can kind of see this is the unsmoothed and this is smoothed. So topology wise, it was mostly edge flow that mattered, and then terminating edge loops. I don't think I had to worry about that in this piece though. I didn't know. But a lot of the time, you'll make a concept piece like this. It's easier to design with. So the good thing about this is that I can, make a change. Like let's say I want to go across here, and let's pull that down. Delete you and you. Oh jeez, why are you like that? And I can pull this back, join you there, and voila, we've got an insert in there. Hang on. Oh, you are so annoying. So the edges, there seems to be double edges in here. Alright, let's merge these. Alright, cool. Yeah. So the good thing is I can make like a change like that, for example, and I can control. I'm gonna have to be very careful here. Is that in line? Yes, that's in line. Yeah. So I can control, like, for example, I want to do that to it, or I want to put it up here. I can change those things. You look at this side, doing it to this side, it's not going to work. It's going to be a lot harder because I'd have to draw the edge along. Okay, you can already see that the edge would flow around. So I can't do it that way. I've got to like draw along it, and then I have to account for the topology I've already put in there. So I'll delete these two, for example. Also, I can, yeah, okay. And then let's say I dragged this across. So I'm doing exactly the same thing I just did, but I'm going to show you why it's a lot harder once you've established the topology to change it. So now, oh, hang on, there's a copy inside there. What is this? No, there's something wrong here. Hang on. Okay, fine. So let's say I want to keep the topology correct. This would then have to go down there, then across, then back up. Now the issue is that you're limiting yourself as to how you can change shapes or where you can go with them, and that's always the issue with yeah, you can see it already, it starts bending out, and then I'll have to fix that and I have to bring this down to match it. It's limiting once you've added the topology. So that's the reason why when I'm concepting, I concept with not bad topology, I concept with no subdividing in mind. It's mostly just about the flow of edges and making sure everything flows okay. Once you know that you know this is the shape I finally want, then you can go in and you can add this the detail into places, because it will start to mess up otherwise. But yeah, I'd say, I don't know, modeling wise, I don't think this piece is that complex. I'll look at a different piece. That is you know what? Actually, that's a good point. Hang on. Okay, yes, yeah. I'll do it for this piece. Well, I can't do it for this piece because it took hours. But it took 2 hours. Jesus. But yeah. So how's the magic done? Here's how the magic is done between this piece and this piece. Let me just make them the same color so it's easier to see. Drone body. And bring this over. Yeah. So, actually, let me. Yeah. With a piece like this, the secret is to make sure everything lands on a flat surface. Now, you can choose where the flat surfaces are. So I've got one here, perfectly flat, and there's one here, and this one, yeah. So that's one flat surface. This is another flat surface. I think everything else is kind of moving in between flat and, you know, it's transient, I guess. That's the best word for it. So if we look over here, this flat surface is the safe spot. I can do whatever I want here, like, doesn't really matter. Let's, like, yeah. And there. Press enter. And when I press 3, it's going to be perfect. There will be no pinching, and that's because it's flat. And that means that it doesn't mean have bad topology, but what it means is that you can be confident that when you're making a shape that's, let's say, cylindrical like this piece here, or you're trying to, you know, end curves, you can always rely on the flat surface to save you in the end. It's kind of like a comfort space. So that's what I tend to do for shapes like this. You try and end them around flat surfaces. So let's just have a look at something. Yeah, you can see what I did here. This edge loop is going a really crazy route. Actually, no, it doesn't mean. Yeah, so I fixed this later, but this is an early part of the save. So you can see this edge loop is coming from like there, going around, it's going up, then around. Let's have a look. Yeah, it's not connected yet. I selected too early, and then it goes up and around here, and then it ends there. Because there's a flat surface here, it doesn't matter, and in the end I probably just routed it across. So if you see here, I'd route this, there, down, and there, straight to another flat surface. So even though the edge loop went all the way around here, I don't have to worry about it pinching. It's not going to pinch, and any edge loop I put across that will not pinch either, because, you know, they always end on flat surfaces regardless of what's going around. That is how you can make a shape like this without any pinching. But if you don't have a flat surface, or it's called planar, that's the actual name, planar surface, then yes, modeling becomes a lot harder, and that's where you get pinching problems. So this is kind of the best example, because this is like a ton of complex shapes, but because everything ended on flat edges, if you can just see here, everything either terminated over there or terminated over, you know, here, this bit, there, where else? Yeah, so even this part is going around and then to this flat surface, and then you try and keep everything away from the cylinders, because the fastest way to mess up a cylinder is obviously to have edge loops like, you know, something like that. Will always mess up the curvature of the cylinder. You can kind of see there, it buckles there. I don't know if you're going to be able to see that actually, but you can see it's not perfect, and that's because I added the 2 edge loops. So you don't want things terminating there. You leave cylinders alone, but everything else can terminate around the flat edges. I'll probably model something from scratch someday, or maybe at the end of this, I'm not sure, but to give you an idea of how that works. Perfect example of not a flat surface is this curve, and that's why you can see the pinching there, and you can just see the limitations I hit, and that's because this is not a flat surface, so it's much harder to deal with, versus this piece here, which is a flat surface, so it was easy to get everything just perfectly flat and smooth there. So yeah, that's literally a comparison from right to left. But yeah, that was this part. Now 9 hours, 11 hours. I think the difference between, yeah, so the difference between these two is just more topology. It's just topology. Yes, it's just topology. So a key point here is that if I just check the topology, actually, I'm just going to turn this off so you can see. Computer struggling. Okay, yeah, we'll use this one. The design of this is pretty much finished at this point, and that's 4 hours in. From 4 hours to 9 hours is simply adding in these edge loops so that I can smooth it. It's getting it smoothable, pretty much subdividable. Yeah. 9 to 11 was the completed subdivide. As you can see, you can just, yeah, you can see that. So it's just getting edges to work, edges not to pinch, and getting everything to flow correctly. Because some of these edges flow a really long way. I'm not sure off by heart how long some of these edges are flowing. Let's have a look. What's this one going? That one stops there. That one goes down. Yeah, so this one's going quite a long way. And when you're like you're doing stuff around here, but you got to know, you know, where it's ending, where it's going. So a lot of this was just high poly modeling. That was just, you know, subdiv modeling. And then what happened is that I got some crit based on the shape. I was lazy here. You can let me just show you. So this shape here is an extrusion of this shape. I've just kind of extruded it inwards, and Alex was like, that's lazy, which he was correct. It was lazy because it was a straight 11 hours and I was tired. So I went to bed and I went back to it the next day, and then I rebuilt it. I rebuilt the entire area, actually. And then I made sure that everything could fit in. So this is kind of like a plug. Let me just show this plug in isolation. Yeah. Right. Yeah. So this was like a plug piece I made for it, and as you can see there, I was trying to make sure that it clicked in as well. So this is kind of the middleman between these two pieces. But also this is intruding in on this like, I guess this part's personal space. It's the best way of putting it. So if I put it together, you can see it looks like a jigsaw puzzle. There's a piece missing, and this piece looks like a jigsaw puzzle. There's a piece missing, and that's where this piece comes in. And this piece is kind of the middle, like the middleman for it. But you can also see that where I kind of lacked the middleman is this flat surface here. They're just next to each other. So what would have made this better, for example, is if a part of this was extruded in to this piece, and this piece had a slot for it. So if I just show you roughly, I'm not going to model it now because it will take me a while due to this shape. But if there was a cut there, let's just say, and then see, the topology is already made, so this is not fun. All right, you know, it's alright. I'm gonna do it anyway for instruction purposes. Let's just go across there. Alright, that'll do. So if that went back, yeah, then you can see that this would be intruding on this piece, which is intruding on this piece, which is intruding back on this piece. Not like that, obviously, but smoother and more integrated. That would look quite cool because they would all fit into each other perfectly. But that takes time. So that's why I didn't do that. This was all a time thing. So I just left it like that. But it was enough. There was enough intrusion that I felt that it looked, you know, it looked snug, let's say. And I liked the underside of this as well. Yeah, which you can see here. Now, I'm wondering if I've got a save of how I modeled this piece. Nope, I don't. But something to show with a piece like that. I'll show how I modeled this quickly. Oh, you can almost see it. So like plane. Oh, that is a key point. Oh no, this is in the center. Where's the piece? I'm not gonna find it. Oh, right, there you go. Yeah. So I model from planes. I don't model from cubes because it's too much responsibility. It's very hard to model from a cube. The reason being that a cube has 6 sides. So when you put an edge loop in, you have to account for all 6 sides. A plane is 1 side. So when you do an edge loop, you only worry about 1 side. It's much easier to deal with. So that's what I tend to start my models with. And that's also why it's easier to avoid pinching. A lot of pinching happens because you're modeling on one side, but you can't see where your edge flow is going on the other side. Then when you turn it around, you're like, whoa, okay, something messed up. So, sorry. A piece like this, ooh, you can, oh, no, let's take this one. Alright, so, hang on, let me, so, yeah, so I'm gonna just rotate this around. Alright, yeah. So a piece like this, how do we want to go about this actually? Alright, let's scale this in. And extrude these out. And then down. Alright. Yeah, that looks about right-ish. Yes, it is. No, yes, correct. It's correct. Alright. And yeah. Alright, so this is another. Oh, actually, no. This. Okay, I'm gonna do one side at a time. Sorry, but this is does it? No, don't use that. So this is a moment where you'd use the D and then line the pivot again. D, select the face, pull down, and now that ensures that it will stay on the same edge. Why this is important is because you want this face to be planar, as I said earlier. D again, and extrude. Sorry, D and down. So. This looks slightly different to me. No, it's not. It's correct. Alright, so making this shape, what you can see here is this is one flat surface, and then I'm transitioning the flat into this surface. And to do that, you select along it, and then you bevel. And you can see what that's done. Oh, go, stay there. So you can see what that's done. And then if you add segments, you can either curve that or you can leave it. I would leave it. So I'll bevel it. Oh, yeah. Okay. So, okay. I'll explain this. So you can bevel it. Now, the issue with, this is why I have broken topology, is this is technically correct topology as of now. But the problem is it affects my bevel. And these edges basically pull in on my edge. And so it kind of, you can see here, that the size of the edge here is not the same as the size of the edge there. It's kind of squashed. So if you delete this, delete edge and delete this edge, which leaves you with a big n-gon, and VFX people cry at this point, but it's okay. You can then select this edge and bevel it, and it'll be closer. Actually, yeah, it's good. It's good. It's still a bit off, but it's fine. You can fix that pretty easily just by scaling that in. So then, I would then select these two edges, and you can bevel that. Oh, hang on, select across there as well. And you can bevel that. And now, what you've got is a transition from this flat face into this side face. I feel like that's probably going to confuse people, but hopefully you got slightly what I did there. I don't know. And if you just go along here, and harden the edge. Join body. There you go. And don't worry so much about the width of it. I'm just trying to give you an idea of how the shape is made roughly. You can see like what's happens there, and then obviously you select these two edges, bevel them, and that gives you the soft edge there. So that is how I went, like, how I approached that shape, for example. Now the difference with this is that it seems totally flat there, which is an interesting way of going about it. If I wanted to do that here, it would be a bit harder though. But yeah, that's like the basics behind that shape. Obviously I was in some different flow when I made that, so I'm not even sure. Nope, we're not gonna do that. That's gonna take a while. Jesus, this piece is ridiculous, to be honest. But yeah, I think that gives you a quick idea. It's not quick, a very long-winded idea of how I came across this. This, by the way, it's just modeled in. It's nothing crazy. That is literally a cube and then kind of scaled in, and that's 4 cubes kind of scaled in. And I just added that to this topology here that was there before, because I think the issue was that you couldn't totally tell it was a battery just by looking at it. And that's where Lars gave me some good credit. I am gonna go and plug Lars. But if you see my work, you've probably seen his work anyway, so you know who this guy is. But he's really good. Concept artist at Massive, so I work with him. And his shit is swaggy. But he gave me a lot of good credit along the way. And he's got like great experience, so he's very good at making more grounded designs than I am, and he just wanted it to kind of shout in your face a bit more. It's a battery, and that's why I did the plus and minus, but I modeled it in to the topology because I didn't want to just plop it on. But yeah, I have a feeling I've left more questions than I have answered, which isn't a problem, but because I'm gonna do more videos and I'll get better at this. But yeah, I guess overall I think that's the battery part done. Total, this was 12 to 13 hours, but this part here was made on a different day, but this was a straight 11 hours, so that gives you an idea of how long it took me to design something like this. Now, to model this from scratch would probably take me, I don't know, 2 hours, maybe. No, actually, yeah, maybe 3 hours for it to be fully subdivided. The design is what took 7 hours. Designing is a lot harder than modeling. And then modeling from the design, yeah, modeling is the easier part, not easy, just easier part. Design is very, very hard. But yeah. For context, those batteries were then placed inside here, yeah, the place you can't see. And you can see it's kind of like this central hub where they kind of led to the center area on the head of the drone, which is what I will talk about tomorrow. But yeah, you can see kind of the complexity level that I tried to keep along the drone. Now the battery, key point, the battery is a bunch of complex shapes, I guess. It was created as one in the beginning, and then I just cut away panel, and split it apart. This shape over here is one complex piece I did not panel apart. So this is all in one mesh, and this came with its own challenges. Hang on. This piece is a bit weird. Hang on. Can I delete that? Right, yeah. Delete this. Delete. What the hell? Delete. Alright, cool. Yeah, so this is all one mesh, and this required a lot of edge. You can see like this kind of weird termination, this edge loop termination, where you turn multiple edges into fewer edges to find a way to terminate it without doing weird endgons. So this, ironically, is, I think, one of the most complex single meshes I did in this drone. And it is a very large surface. The reason why I kept this one piece, by the way, is because if I had paneled this up, it would become a detail area, and it would have become, I guess this part is a detail kind of area, but the whole thing would have become a detail area. And I wanted this area to be like an area of rest to contrast to this area here, which is quite a lot of detail. So it kind of forced me to have to model everything into one shape. But it does look quite nice, and I was really happy with it, so I can't complain. But yeah, paneling is like a very easy way of adding detail and making your life easier. And the reason why it makes your life easier is because you can terminate the edges down the side of a panel. So it means you don't have to worry too much about where the edge is going. You know it's going to the end of the panel, and the panel is on a straight edge most of the time. Perfect example is here, like all of these edges, they just flow down the side, so it's fine. But if this was all one shape, this edge would have to end, let's say, for example, halfway inside this circle. And then if I don't have the right amount of edges in the circle and it doesn't line up to the shape, then you'd get this weird pinching area. So by having a panel there, I can just end it there. And then these circles, I have this circular panel here, which means I can be lazy and end them like, just along the side. And that way I don't have to worry about it flowing around here or flowing into this area here. That's also why you'll notice that there's a ton of topology, and then there's just a gap. And that's the thing that, paneling helps with. At the same time, I also get the added benefit of having a panel. So it looks like, oh, this was put together. It's win-win. It's one of the best win-wins you can have. Because you get the aesthetic of the panels and you get the simplicity for the modeling side of it. The downside is that you have to design the panels in a way that's aesthetic, makes sense, and doesn't draw away too much from the shape itself. You want the panels to kind of accentuate the shape, the overall shape, and draw your eye along it, so that's the downside, I guess, balance. But otherwise, yeah, I'd say it's a kind of secret weapon that you can utilize, and it works well. People like panels, so I think overall that's the main overview. I'm tired, so I'm starting all over the place, but it doesn't matter. It will be enough. Tomorrow I'm going to do the proper overview of the entire drone, and that's the serious one, let's be honest, because this thing was a mother. Oh, hello. Okay, I'll check that after. But I'll be doing the overview of the entire drone and going through, the decisions that I went along this. This is, I think, 300 saves. So that's going to be one hell of a long video. It's 350 saves. The final file size was 1.8 gigabytes. You can see it's 1.8, 1.1, 1.3 per save. So this folder's huge. But yeah, I'll go over that tomorrow. So thanks for watching.